In this lesson, we're going to talk about ions, both monatomic and polyatomic. We're going to explain how and why ions are formed, and we're also going to look at the number of subatomic particles found in ions. We need to talk about ions because when we look at ionic compounds, it's formed from ions. And so the definition of an ion is a charged particle that results from the gain or loss of electrons. Now, when we look at a cation specifically, a cation is a positively charged particle, and it results from the loss of electrons. An anion is a negatively charged particle, and it results from the gain of electrons. So when we looked at the example of comparing neon to oxygen and fluorine and sodium and magnesium and talking about gaining or losing electrons, it's those elements that will gain or lose electrons to form ions, and the octet rule will help us figure out how many electrons are gained or lost. One way to help you remember the difference between cations and anions is to think about cations being positive because cats have paws. So first, we're going to look at monatomic ions. So let's break down this phrase, monatomic ions. So we know the prefix mono means one, atomic means atom, and an ion means a charged particle. When we have single atoms with a charge, those are monatomic ions, and we see some examples of them below. When we look at polyatomic ions, we can break this down as well. Poly means many, atomic means atom, and ions means charge. So in this case, we have many atoms together with a charge, and these function as a group. Here are a few examples shown. Notice that we have multiple atoms together, and overall that group of atoms has a charge. One thing you need to know is that you only need to recognize polyatomics. You do not need to memorize their names, formulas, or charges. Let's look at an example of how a cation forms. We know it forms through the loss of electrons. And so when we look at beryllium, we see it has 4 protons, 5 neutrons, and 4 electrons. When we look at the ion that forms, if we go back to the electron arrangement, we'll see that we have 2 valence electrons in beryllium, and so it's going to lose those 2 electrons because it's going to try to look like the nearest noble gas, which for beryllium would be helium, which has 2 electrons. So when we look at the beryllium 2 plus cation, we see that it still has 4 protons and 5 neutrons. Remember, the number of protons determines the identity, so it will not change. Neutrons are neutrally charged, so the gain or loss of neutrons won't lead us to that charged particle. So what we're looking at are the electrons. Because we have a 2 plus charge to form a cation, that means we have lost electrons, and so we have 2 electrons. When we look at the charges, we know that protons have a positive 1 charge, so we have plus 4 from the protons. 2 electrons, each with a minus 1 charge, so we have minus 2, and that results in an overall charge for the ion of plus 2. Anions form through the gain of electrons. So when we look at an atom of chlorine, if we have 17 protons, 18 neutrons, and 17 electrons, what we see is that we have a neutral atom. In order to form that anion, in this case with a minus 1 charge, because chlorine has 7 valence electrons, it needs to gain 1 electron to look like the nearest noble gas, and so it's going to gain 1 electron. And so we still have 17 protons and 18 neutrons because it's still chlorine, so it must have 17 protons. And then we get 18 electrons. So we've gained 1 electron to have overall a minus 1 charge. Because we have 17 protons, each with a plus 1 for a total of plus 17. 18 electrons, each with a charge of -1 for -18, and overall our charge is going to be -1. Remember that neutrons are neutral and do not contribute to the charge in an atom.